Hello everyone, welcome to Lab 5. In this lab, we are going to dive into how the digital inputs operate on the MOVIDRIVE. We will demonstrate controlling the MOVIDRIVE with its default input assignments and how to modify them in the parameter tree. One of the ways to operate the MOVIDRIVE is with digital logic. The digital logic is binary on and off signals that correspond to ones and zeros in the processor. These on and off signals come from external control voltages switching on and off. These signals can range from 0 volts, which is interpreted as a low signal, and 24 volts, which would be interpreted as a high signal. There is some allowed tolerances of the voltage range, but it shouldn't exceed 30 volts, otherwise the circuit could be damaged. The MOVIDRIVE works with sourcing inputs, meaning that the voltage supply wire is switched to actuate the input. There are other technologies used in the industry that use lower voltage levels or syncing inputs where the common wire is switched instead of the voltage wire to actuate the input. So I just want you to know that there are other types of digital logic out there that you could encounter. You will also need to always confirm the voltage levels and how the input is actuated before connecting the wires so the input works properly. For this training program, we will be using manual switches to actuate the inputs. But binary control doesn't have to come from a manual switch. There could be a PLC running a program that uses its outputs to actuate the inputs of the MOVIDRIVE. There could also be limit switches or proximity sensors to actuate the inputs. So there is some flexibility here with where the signal comes from. The important thing to verify are the voltage levels and that the signal is a sourcing type signal where the voltage wire is switched instead of the common wire. The binary method using logical ones and zeros continues with how some functions in the MOVIDRIVE operate. For example, if we look to the set point speeds, there are 3 different speeds to choose from for each parameter set. Because of the binary logic, we only need to use 2 input terminals to actuate 3 different speeds. So if you remember from the previous training sessions, N11, N12, and N13 are set points 1, 2, and 3 for parameter set 1. And N21, N22, N23 are the set points for parameter set 2. For this example, we're going to be using parameter set 1. If both fixed speed set point inputs are off, then there is no fixed speed that is selected. If we only activated the N11 input, then the MOVIDRIVE would operate at set point 1. If we only activated the N12 input, then we would be using set point 2. There isn't an input parameter available for N13, so to use set point 3, we have to activate N11 and N12 inputs at the same time. Now, if you wanted to use the set point speeds of parameter set 2, there is a caveat where you will need more than 2 inputs. Since parameter set 2 is optional, you would need to program a third digital input to be dedicated to the function that's called fixed set point changeover when you want to use these other set point speeds. When you program the digital inputs, you will encounter different functions, and some of them can have different active levels. The active level determines with binary logic whether an action has occurred, and the active level also determines what state triggers the programmed function. There are 2 active levels. Active low means that when the input does not have voltage, the programmed action is performed. When the input does have voltage, the action is not performed. Active high means when the input does not have voltage, the programmed action is not performed. When the input does have voltage, the action is performed. The active low conditions are common with fault events and the inhibit terminal. You should also recognize the slash in front of the function. The slash means that the function is active if the terminal does not have voltage. This is why there has to be voltage on the inhibit terminal to clear the MOVIDRIVE from the inhibit state. The active high conditions are for inputs that are active when there is voltage present on the terminal. These can be your enable switches, set point speeds, and direction of rotation functions. And there is no slash in front of the function, so that means it is active high. Okay, let's go to the software and use the terminals to operate the MOVIDRIVE. The first thing we can do is rename our MOVIDRIVE. So I will right-click on our MOVIDRIVE, come down to the item that says Properties, and then give it a name. Now I'm just going to call it MDXB VF for the operating mode that we're in, and then click on OK. Now let's go to the parameters and open some that we will want to look at as we operate the motor from the manual switches. So I'll right-click on the MOVIDRIVE and come to Startup, and then Parameter Tree Online. I'll open up folder 0, then item 00, and then item 3 for the binary inputs of the basic unit, and then item 5, the binary outputs of the basic unit. The first thing I want to do is make sure that the set point 1 dial is all the way to the left, and it is. Now let's activate 3 switches and see what happens on the MOVIDRIVE. I'm going to activate the inhibit to clear it from the inhibit state. I'm going to activate digital input 0, 1. And then now I'm going to activate digital input 0, 3. All right, the motor is now turning clockwise at 15 RPM. Now you may be wondering why the motor is running at 15 RPM. Well, this is the default minimum speed from our motor startup procedure. So let's go find that parameter. It's in folder 3, motor parameters. Item 30, limits 1. And then here it is right here, parameter 301, minimum speed at 15 RPM. And what that means is if the MOVIDRIVE has a direction of rotation and an enable, even if we do not give it a speed, it will start running at 15 RPM. And we're currently not giving it a speed set point, so that means it's a 0 set point. So it's running at 15 RPM. Okay, so I'm going to close this. Okay, now let's rotate the set point dial and see if we can increase the motor speed. So I'm going to bring it from the left all the way to the middle. And it appears that had no effect on the speed, so let's keep going. All right, now we're increasing speed. And now our speed is at the maximum setting of 1800 RPM, and we can see that here in the parameters. Now let me take the set point 1 dial back down to the middle. And now we're back down to 15 RPM in the clockwise direction. Do you have an idea of why our set point 1 dial is only changing the speed from the middle point all the way to the right? Well, let's investigate why. So I'm going to open up the analog set point parameter, which is item 2 right here. And then if we look at parameter 020, we can see that our voltage level is currently negative 0.98 volts. So now let's open up parameter 100. So that's in folder 1 for the set points and ramp generators. item 10, the set point selection. And then our set point source says unipolar or a fixed set point. So in our default configuration, what this means is we have to give the MOVIDRIVE a direction of rotation for clockwise or counterclockwise to get it to go that direction, but it's unipolar, so that means it's only looking at the voltage signal from 0 volts to 10 volts. If I take this set point 1 dial and move it to the left all the way out, you'll see that the voltage now says negative 10 volts. So that would technically be the counterclockwise direction, but since we have our set point source set to unipolar instead of bipolar, we're ignoring that negative voltage value. Okay, let's close these. Now let's turn on both directions of rotation at the same time and see what happens. Okay, the MOVIDRIVE stopped and the brake enabled. Okay, so we can see if we tell the MOVIDRIVE both directions of rotation, it activates the stop because it does not know which direction it should rotate. All right, let's turn off the counterclockwise direction so it runs again. And then let's increase our speed and then test different stop functions. So we're going to go about right here. And we're running at 1026 RPM. So first, let me deactivate DI03. If you look at the parameters, you can see that DI03 is the enable stop terminal. So let's go ahead and deactivate that. All right, that was a pretty gradual stop. And once it stopped, it enabled the brake. So let's reactivate the enable and run the motor again. All right, and then now let's deactivate DI00, which is the inhibit, and see how that works. That was much worse. That was very abrupt, and the motor jerked when it stopped. Do you have an idea of why the motor jerked? Well, the reason the motor jerked is because we deactivated the inhibit, which means it does not use any kind of ramp times. It just cuts off power to the motor immediately and engages the brake immediately. So it's an uncontrolled stop. When we drop the enable signal, that is a controlled stop, meaning that it uses a deceleration ramp to get to 0 speed. It does not just engage the brake immediately and then cut off voltage immediately. So you do have to be careful with deactivating the inhibit while the motor is running because it will be an uncontrolled stop. So let's reactivate the inhibit and the motor will run again. All right, and then now let's turn off the clockwise direction of rotation, and we can see that our input is assigned as clockwise/stop, and let's see how the motor behaves when we deactivate the direction of rotation. Okay, and we can see that it deactivates just like the enable signal. So the way this is currently set up in its default configuration, we can deactivate the direction of rotation input or the enable input, and the MOVIDRIVE would come to a stop using the stop ramps. Now let's turn the set point dial all the way to the left and then test the set point speeds. So I'll need to turn off the inhibit and then come into the parameter tree and look for the set point speed parameters. So that's going to be parameter 160 is the first set point speed. So that is folder 1, item 16, fixed set points 1. And then our parameters are 160, 161, and 162. Now don't get confused by these percentages here. That's only used if you are in a torque control mode where you're setting a percentage of the MOVIDRIVE current. So we're going to ignore these since we're not in a torque control mode. We're only doing speed control. So let's change some of our set points. So let's change parameter 160 to be 100 RPM. And then I do have to press the Enter key on the keyboard to take that change. And then let's set N12 to be 200 RPM. And then press Enter. And let's change N13 to be 300 RPM. Now let's test run the MOVIDRIVE using the different set point speeds. So the first thing I need to do is activate the inhibit, so we clear the MOVIDRIVE from the inhibit signal. And then I need to activate a direction of rotation. So I'm going to choose clockwise again. All right, the MOVIDRIVE is now turning slowly at 15 RPM. Our dial is all the way to the left. So now let's activate our first set point speed. And we can see that our first set point speed is going to be digital input 04, which will be N11. So let's turn on digital input 04. All right, and the motor came up to speed. And then we can see here in our parameter that the speed is at 100 RPM. Now let's activate N12 speed, which to activate that, I need to turn off N11. The motor will slow back down. And then now I need to activate N12, which is digital input 05. All right, the motor is up to speed, and we can confirm that it says 200 RPM. Now to activate N13 speed, there's not a dedicated input for that. So I need to activate N11 and N12 at the same time to turn on N13. All right, here we go. And the motor is just a little bit faster. And we can see that our speed readout is now 300 RPM. Okay, let's go ahead and stop the MOVIDRIVE by dropping the enable signal. All right, and the MOVIDRIVE stopped. Now, if we wanted to run in the counterclockwise direction, what do we need to do to use a positive set point speed but run in the counterclockwise direction? Well, all we need to do is just activate the counterclockwise direction input. So we still have 300 RPM activated as a set point speed. We've turned off our enable, and we've turned off our direction of rotation. So now let's turn on the counterclockwise direction and then give it the enable signal. And we'll see now that the motor is turning at its 300 RPM set point speed, but it's running counterclockwise. Okay, let's stop the motor. And then let's turn on the inhibit by deactivating the inhibit terminal. Now let's say that we don't want to assign our set point speeds to the default inputs of digital input 4 and digital input 5. So let's change our input assignment. And we can do that by going to folder 6, which is terminal assignment. And then item 60, binary inputs of the basic unit. And then let's turn our N11 and N12 inputs that are currently programmed. Let's turn those to no function. So that's all the way at the top of the list. And then we'll turn this other one to no function. And then let's say we want to move that to digital input 6 and digital input 7. So I can just come to digital input 6 and scroll through the list to find N11. And then digital input 7, change it to N12. Okay, and then now we can test run this and make sure our input assignment has changed. So I'm going to clear the MOVIDRIVE from the inhibit by turning the inhibit terminal on. And then if I give it the enable signal, counterclockwise direction as well, we'll see that it's only running at the minimum speed of 15 RPM because we still have our old inputs activated that are set to no function. So let's turn these off and then use our 6 and 7 that we just programmed. So here is input 6 coming on, which should be the N11 speed of 100 RPM, but it's in the counterclockwise direction, so you see the negative in front of it. Now let's activate N12 at the same time, which should be our 300 RPM set point in the counterclockwise direction. Here we go. And now we're running at negative 300 RPM. Okay, so changing those inputs worked. So let's deactivate the enable to stop the motor. All right, let's close these inputs. And then let's open up our optional inputs because this MOVIDRIVE has an expansion card installed for additional inputs and outputs. So that's going to be item 61, binary inputs of the option card. And then we can see its default configuration says that everything is no function. So let's change digital input 10 to be a fault condition. So let's click on the arrow to see the list and scroll through here until we see /external fault. And here it is right here. Okay, it told me the controller inhibit needed to be required. So I forgot to do that. So I need to activate the inhibit on the MOVIDRIVE by turning off the digital input 00 terminal to allow a parameter change. Okay, and then now let's click the OK button and then try that one more time. Now let me make the change. Now there's a slash in front of this external fault. So if I just ran the MOVIDRIVE as it is right now, what do you think would happen? If you think the MOVIDRIVE would start to fault, you'd be correct. If I try to run the MOVIDRIVE right now without this input turned on, the MOVIDRIVE would start faulted. So let's test that. So I'm going to leave our set point speeds on for 300 RPM. I'm going to give it the enable signal, and then I will clear the inhibit. All right, as soon as I did that, the MOVIDRIVE faulted, and we can see this fault by coming to the online unit status, right-clicking in the area, saying display all units, and then there it is right there, fault 26, external terminal is faulted. And that's because we do not have any voltage going to this terminal that's assigned to external fault. Now, an example of when you would want to use external fault would be, say, for instance, if you have multiple drives that need to run together, if one of those drives happens to fault, the other MOVIDRIVE may not know it has faulted. So you would want to tie an output from one drive to the input of this one, so that way it can monitor if it is faulted or not faulted. So currently we don't have voltage to that, so let's put on voltage to that first, which is digital input 10, which will be this switch here. All right, and now we have the check mark saying there's voltage going to it, but now we need to clear and reset the fault. So now I will press the reset button. All right, now the fault is reset, and then as soon as the fault resetted, the MOVIDRIVE took off immediately at the 300 RPM set point. So that was because I had all the conditions true to make it run, and then including the external terminal was true as well. So you do have to be careful with that if you reset a fault and then all the true conditions are going to the MOVIDRIVE, it is possible for it to take off immediately as soon as the fault is reset, and then it does not have any other issues with running. Do you have an idea of what would happen if we triggered the external fault while it was running? Well, let's test it. So I'm going to turn off digital input 10, which will activate the fault condition on the MOVIDRIVE. Okay. It used a slight ramp and then it stopped immediately, so it wasn't as abrupt as the inhibit, but it was still pretty quick when I activated the fault. And then we can see that the fault is now back down here in the bottom. Now, if I wanted to reset the fault with the input off, let's try that. Okay, it lets me reset the fault, but it immediately comes right back because we have not cleared the external terminal fault. And then all the other signals to run the MOVIDRIVE were true, so it still needed that external terminal to run. So when you're resetting these external terminal faults, you do have to make sure that the input is active again before you reset it, because it will immediately come back if you try to run the MOVIDRIVE and the input is still not true. So now let's do this a safer way. Let's turn off the enable input, so that way the MOVIDRIVE cannot run. Then now let's turn on the external terminal fault. And we can see the motor did not take right back off because we have yet to reset the fault. So let's press the reset button and see if the MOVIDRIVE will start automatically. Okay, the MOVIDRIVE did not restart automatically because we have removed the enable terminal. So now let's activate the enable. And there we go. The MOVIDRIVE is now running again at 300 RPM in the counterclockwise direction. Okay, let's stop our motor from turning. So I'm going to turn off the enable signal. Let me show you the ramp time where this external terminal fault comes from. So let's close the binary inputs option and then close this reset window as well. Then we can close the fixed set points as well. And then let's collapse some of these menus so that way we don't get confused. Now first, let's inspect where the ramp time comes from if the MOVIDRIVE is faulted while it's running. So that's going to be in folder 1, Setpoints/ramp generators. And then item 13, speed ramps. We have a full list of speed ramps here. We can see there are 2 ramps up and down for the clockwise direction, 2 ramps up and down for the counterclockwise direction. And then we can see here that we have a stop ramp and then an emergency ramp. Now the difference between these are the stop ramp generally is when you deactivate the enable signal. So when I toggle off DI03, the enable signal, it is using this stop ramp parameter right here. If I toggled off one of the directions of rotation, then it would be using the ramps up here at the top, depending on which direction of rotation I toggled. And then the emergency ramp is specifically for fault conditions. So now let's look at our fault conditions and see which ramp the external terminal fault would use. So let's go to folder 8, unit functions, and then item 83, fault responses. And then we can see right here, the response to the external fault is using the emergency stop/fault. So it's using this parameter 137 ramp if the external fault occurs on the MOVIDRIVE. Now we can click on this drop-down menu and see there are other fault conditions to choose from. Now let's say, for instance, we want to use the emergency stop ramp for specific scenarios, but we don't want our external fault terminal to use that ramp parameter. We just want it to use the normal removal of the enable parameter. So we can change emergency stop to be rapid stop. And this will use the same ramp time as deactivating the enable. So let's change this ramp time to something that's very long, so that way we can see that it's using this ramp time when we trigger the fault. So I'm going to change this to 10 seconds and then press the enter key. All right, and then now let's test run this motor with this new ramp for the enable. So now I will bring the enable high. And we can see now the motor is turning at 300 RPM. And then if I deactivate just the enable, we'll see how long it takes. Okay, it didn't take a full 10 seconds because we weren't going that fast, but it did take a little bit longer than it used to. So let's run that again and see if it stops in the same behavior by deactivating the external terminal fault. So I'm going to trigger the fault on the MOVIDRIVE now. All right, and we can see that it was not as an abrupt fault condition. So that way you can reserve the emergency stop ramp for specific scenarios that you see here that may be more important than just the external terminal being triggered. Okay, let's turn off all of our switches. And then now we would need to reset this fault so that way we can run the MOVIDRIVE again. So I will come to online unit status on the bottom. It remembers that I populated this window with the device, and then now I can just click on reset. And now the MOVIDRIVE is reset and ready to run another time. Now, since we still have the external terminal input programmed, if I wanted to run this again, I need to make sure that this input is active to run this again. All right, that's the end of Lab 5, and we went through how to use the digital inputs to control the MOVIDRIVE and then some of their default configurations. We also demonstrated how to change some of those default configurations if you want to make your own customizations. We briefly showed how certain fault situations can have different responses and ramp times. We changed one of the deceleration parameters to 10 seconds, but the motor came to a stop in a much shorter time than 10 seconds. In the next lab, we will discuss how the ramp time parameters are scaled and how you can use equations to determine what value you should enter as a ramp time, so you can optimize the control of your motor. Thank you for your attention. Take care and have a good day.